Hey guys, welcome to this video on 8.2 Writing Linear Equations Part 2. In this video, we're going to be writing some more linear equations and we're going to be looking at how those equations are connected to tables and graphs. Super fun stuff. To start with, we're going to take a look at this engage problem here. The length of a rectangle is twice its width. Make a table to show 5 possible values for the length and the width, then draw a graph to show how the length and the width are related. Alright, so let's try this problem here. The length of a rectangle is twice its width. So I'm going to draw a rectangle. I'm not going to draw it like this because the length is like, I don't know, 10 times the width. So that's not how I'm going to draw it. I'm going to draw a rectangle that looks like the length is about 2 times as long as the width. So that's what my rectangle should look like. Now, make a table to show 5 possible values for the length and the width. Well, if one is 2 times the other, maybe this side is 3, that's just a possibility, and if the width is 3, what does the length have to be? It would have to be 6 because it has to be 2 times as big. So in my table, I'm going to say length and width. And we said if the width was 6, if the width was 3, then the length was 6. So that's one possible answer. Well, what if the width was 2? If the width was 2, then the length would have to be 4. So you're just kind of making a table to show some different possibilities. So let's make another possibility. Let's say that the width is 5. If the width is 5, then the length might be 10. Whatever it is, it just has to be 2 times as much. They wanted 5 values. Okay, we did 3 so far, so let's do 2 more. If the width is 1, the length is 2. And if the width is 8, the length is 16. It always has to be 2 times as much. All right, now the last part of this problem, they want us to draw a graph. When we draw a graph, we're going to use a coordinate plane. A coordinate plane is going to have an x-axis and a y-axis, and we're going to graph some of the numbers on this x-axis here. We're going to graph the other numbers on the y-axis here. We're going to actually say that the width is going to be the x-axis, and in this problem, we're going to say the length is going to be on the y-axis. So the first number that I have here is I have a coordinate pair that I could write like this. When we write the coordinate pairs, we always want to put the x's first and the y's second. So to graph it, I'm going to say 1, 2, 3. 1, 2, 3, 4, 5, 6. Okay, so that could be my first point on the graph would be 3, 6. I could make another point for 2, 4. I would go over 2 and up 4, and that would be another point. I can't on this graph show 5, 10 or 8, 16 because I didn't make it big enough. I could show 1, 2, and that would be right there. So to make our graph, we're just taking the points that are in the table and we are putting them on the graph. Once you make a graph, because we are doing linear equations in this section, linear means that they're always going to form a line. So once you're done plotting the points, you can draw a straight line between the points since it is a linear equation. Alright, I know that that was a lot of information that we just kind of threw at you at the very beginning of the video. This is basically everything that we're going to be doing today. So if this part was a little overwhelming, don't worry, because it's not going to get more difficult than what we just did. We're basically going to take what we just did and we're going to do it several different times in several different example problems. So this was just the first example problem. I'm going to walk you through 2 more example problems and then you guys are going to try some on your own. So in the example problems that we do, we're going to have a problem like this. We're going to eventually make a table kind of like that, and then we're going to make a graph kind of like that. So let's take a look at the first problem. In this first problem here, we are taking a look at the length of a rectangular picture frame, and the length is 5 inches longer than the width. So not 5 times as much as the width, but 5 inches longer than the width. So in this problem, we are adding 5 inches to the width. If we want to write down an equation to relate the length and the width together, we could say the length is equal to the width plus 5. Whatever the length of the picture frame is, we're going to say it's the same thing as the width plus 5 more. So if this is a certain number here, like let's say this is 7, then this one would be 7 plus 5. Down here, they've shown some different options, some different examples. Maybe the width is 1. In that case, 1 plus 5 would give us the length of 6. Maybe the width is 4. In that case, 4 plus 5 would give us the length of 9. You can take these examples here and you can write them in a table. This is what the table would look like. Right down here, this is what the table would look like. We took the same numbers that were up here in the example and we just put those numbers into a table format so it looks a little bit more organized. So today we're going to practice with taking numbers that are kind of like practice numbers and organizing those numbers into a nice, neat table, just like this table here. After you organize the numbers into a nice, neat table, then you can do the third step of graphing the numbers. When you graph the numbers, all of the numbers that are in the table that are connected together are going to form ordered pairs. Down here they say the ordered pairs are 1, 6. They got that from these numbers right here. The 1 and the 6 in the table, that forms an ordered pair of 1, 6. 2, 7, they got that from these numbers here. 3, 8, they got it from these numbers here. So all of the numbers that are kind of practice numbers, those turn into the table, and all the numbers from the table, those turn into ordered pairs, and all of the ordered pairs, those turn into a graph. This is what the graph for this problem is going to look like. The graph is going to look like this here, and we again got that graph by looking at the table. So the first ordered pair 1, 6, on the graph, we would go over 1, so this is where the 1 is, and then we would go up 6, this is where the 6 is, and this is where they put the first dot, 1, 6. Then they looked at the next number, the 2, 7, and they went over 2 and up 7, and they put the dot right here on 2, 7. They did that for all of these. The next one is 3, 8, and the dot ended up right here at 3, 8. And then they did 4, 9, which ended up here. And finally, 5, 10, and the dot ended up here. Once they put all of those dots there, they noticed, hey, all of these dots are in a straight line. That will always happen in this section because we're doing linear equations, so they always happen to be in a straight line. And the cool thing about that is once you have a straight line here, that line actually can help you to find other numbers that could go in the table as well. Because these are not all the possibilities right here, there's actually more possibilities that we could put in the table. For example, the dotted line that they put here, they're using a decimal. This dotted line that they put on the picture that's using a decimal, that's one more option that you could put in the table if you wanted to. They're just showing you that once you have a line, once you have a straight line and you graph it, it opens more opportunity for you to find even more things that you can include in your table. All right, let's move on to one more problem. So this problem here says each can of paint contains 5 gallons of paint. This is what a picture might look like. So one can of paint, like this one can right here, has 5 gallons of paint inside of it. So 1 can is equal to 5 gallons. 2 cans are equal to 10 gallons. 3 cans are equal to 15 gallons. If I want to write down an equation, remember equations have to have an equal sign. If I want to write down an equation for the number of cans and the volume of the paint, I'm not going to say that the number of cans is equal to the volume of the paint because 1 is not equal to 5. I'm going to have to add or multiply or subtract or divide or something in my equation. What kind of an equation can I write here that's going to relate some of these numbers together? I'm noticing that if you take the numbers on the left and you multiply them by 5, you get the numbers on the right. So I could say that the volume of the paint, which is right here, the volume of the paint, is equal to the number of cans times 5. And usually we would write the number first, wouldn't we? So usually we would say 5 times C. That's how we would write it. So the volume of the paint is equal to the number of cans times 5. So that would be an equation that you could write down for this problem. Once you write down an equation for this problem, now let's write down a table of values for a whole bunch of different possibilities. We already have 3 possibilities here. We have 1 and 5, 2 and 10, 3 and 15. Let's write down some more possibilities. Here are some more possibilities that you can see in the bottom. So we already did the 1 and 5, 2 and 10, 3 and 15. Another possibility is 4 and 20. Another possibility is 5 and 25. These are not all of them. We could keep going. We're just writing down some possibilities. So in this table, we have a nice, neat way to organize all of our different options that we've thought of so far. Now remember, the next step is to take these options that we've thought of and we want to put them on a graph. In order to put them on a graph, we're going to need to come up with some coordinate pairs. Let's take a look at what that's going to look like. So I'm going to write down a coordinate pair here, 1, 5, and then this one is going to be 2, 10. Then we have a 3, 15, a 4, 20, and a 5, 25. Now let's look at how we can put those on a graph. First, for the 1, 5, I'm going to go over 1 and up 5, and it's going to end up right there. For the next one, the 2, 10, I'm going to go over 2 and up 10, and I'm going to put a dot right there. The next one is 3, 15, and the dot ends up right there. Then there's 4, 20, which is here. And lastly, we have 5, 25, which is going to be right here. Now, if you're looking at the graph, you're going to notice that they put some additional points on. Remember, these additional points are more options because we didn't include all of the different options when we were doing our table. So they're just showing you that because all these points are on the same line, any other point that's on the line is going to be another option that could fit into our table if we wanted it to. All right, I think you're ready to try a problem on your own, so let's take a look at it. This problem here has a few different parts to it. Go ahead and pause the video, give this problem a good long try. Take your time with it because we're almost at the end of the video, so feel free to take as much time as you need to work through this problem. Once you're done, then you can come watch the video for the answer. Here's the answers, so you can go ahead and check your work, and let's talk about the answers and why they got these answers that they did. So the first one says, if the length is P and the width is Q, write an equation. Well, it said the width of a rectangular tank is 2 meters less than the length. So we're going to subtract 2 from the length in order to get the width. So this equation is saying that the width is equal to the length minus 2. They just used variables to represent the width and the length. They said the width, we're going to call it a Q, and the length, we're going to call it a P. But really, this is what the equation says. Width is equal to length minus 2. All right, the next part. Fill in the missing numbers in the table. Well, we can use our equation here, and we can just subtract 2. 4 minus 2, that's how they got the 2 there. 5 minus 2 gave them 3. 7 minus 2 equals 5, and 8 minus 2 equals 6. The next part, they want you to use the data from the table to plot the points on the graph. To do that, remember, you're always going to make your coordinates like this, and you always take the number that is in the top of the table. That's always the first number. So it's always going to be 3, 1, 4, 2, 5, 3, etc. This is what it should look like here when you plot all the points. This is 3, 1, this is 4, 2, 5, 3, etc. And then the last part here is saying the point 5.5, 3.5 is on the line. So let's test that out. 5.5, 3.5. This is where that point would be that they're talking about right now. Would that make sense in this situation? The answer is yes. It's possible that if you subtract 2 from 5.5, then you can get 3.5. So yes, that is a possibility, and we know that also because it is on the line. All right, so you just did one entire problem on your own. We only have one last problem for you to do today, and that is this problem right here. Go ahead and pause the video, try this last problem, and then you can come back to check your answer. All right, so here's the answer. The first part said to plot the points and then to connect them. So I haven't connected it yet because I wanted you to see where all the dots were. So I put 1, 50, 2, 100, 3, 150, and 4, 200. I ran out of space, so I didn't do the last two, but that's okay. So they would still be on the same line as everything else. So this is where all the dots would go, and then you could connect the dots, and you could make it form a line like this. And then to get the equation, I'm noticing that if I take this top number and I multiply it by 50, I get the bottom number. 1 times 50 is 50. 2 times 50 is 100. 3 times 50 is 150. 4 times 50 is 200. Once you find out what the pattern is, you're kind of like looking for a hidden pattern. And once you find that pattern becomes your equation. So again, the pattern is that you're multiplying it by 50. So I write down the bottom, which they used a D for the bottom. So I'm going to say the bottom number D is equal to the top number T times 50. The bottom number is equal to the top number times 50, but they actually wrote the 50 first. That's how you're usually supposed to write it. So D is equal to 50 times T. All right, that's it for this video. Great job. Go ahead and submit your notes to Canvas, and then you are done with this video.